Currently, it is estimated that almost 15 million people worldwide suffer from quadriplegia. Think about it, that's 15 million people who can't go for a walk, who can't go out to see friends, and who can't even drink a glass of water without help. Add to this the fact that many quadriplegics don't have access to a proper wheelchair, and you begin to understand how serious this problem is. A proper chin-controlled wheelchair can cost upwards of $25,000 on the low end, and even then, users can still complain from neck pains and neck cramps because of overuse. We aim to solve this problem with our solution, the HeroChair.
I am an options teacher at STEM Innovation Academy High School, and in our mechatronics and programming courses, students have a project credit where they get to use their technical skills learned in the course to help in their community. They brought their passion projects that they had started developing in their courses together to create a wheelchair that uses brain waves as control, as well as augmented reality, and then the mechanics from their Swerve Drive module from their FRC room.
Our solution was to make a wheelchair that can be controlled using only the user's eyes. In phase 1, we wanted to use the Muse to control the wheelchair. While this is possible, it has limited output capability, which is why we decided to incorporate the HoloLens 2 for eye tracking capabilities in phase 2.
This is a Swerve module. What is so unique about this is that it can rotate 360 degrees while also providing power to the wheel at all times. This allows our robot to rotate, translate, and drive forward at all times. These Swerve modules are able to take a beating. They can survive high-speed collisions, and they should be plenty durable for the wheelchair that we're using. All the parts on our wheelchair are commercially off-the-shelf products. This should make replacing and upgrading the wheelchair over the course of time much easier and much faster.
This is the prototype we came up with, the HeroChair. As seen here, a user can set a position simply by staring at the ground. When the user raises their eyebrows, the location of the waypoint is confirmed and will be displayed to the user on their visor. Now, when the user looks to a panel on their left, the eye tracking in the visor will detect that, and the wheelchair will drive to the desired location. What's more is that this wheelchair can move freely in any direction, allowing for enhanced mobility and better access in narrow spaces or winding corridors.
The headset scans the surrounding areas to determine if there's any obstacles or dangerous terrain that may pose a harm to the user. This allows anybody to use the wheelchair with little to no experience.
As I mentioned before, everything is easily replaceable, modifiable, and upgradable. All the parts on the robot can easily be purchased off the shelf and in large quantities, which allows for easy scalability. And many of these parts can be easily CNC'd.
When incorporating technologies like the Muse headband and the HoloLens, they will have their limitation. Our software bridges these gaps.
When the user decides to place a waypoint in world space, we get the vector data, write that to a JSON file, which is then read by a Python script and sent over to the robot via network tables. As the Muse collects real-time signal data, it will then use the same Python bridge to communicate back with the HoloLens and drop a waypoint at a location.
In Alberta, the primary source of support for physically disabled individuals with quadriplegia or locked-in syndrome comes from basic subsidiary programs like AADL or RAMP. Those programs only cover basic medical equipment needs and don't physically allow for the full compensation.
The total cost comes to around $8,700. This is a third of what the high-end to medium-end chin-controlled wheelchairs are on the market right now. This means over 15 million people can now reaffirm the quality of life they deserve for around $17,000 less than it was previously possible.
This is exactly what we believe the HeroChair can solve. Its simple design allowed a team of students to complete it in just 4 days, while its 360-degree mobility makes it more maneuverable than anything else on the market. This is only the beginning. We hope to improve this design by adding a more comfortable chair, by replacing the battery to last for days instead of for hours, and to get real feedback from real patients in need. We've never seen someone use this kind of technology before, and I truly believe that this has the possibility to revolutionize how 15 million people live their everyday lives.